And actually, I have a lot of questions to scroll through here. So if it's okay, why don't I do this? Why don't I mute everybody back up? I think the first question was Mark. You were asking about, is the neodymium effect, do you still have that one?
So I'm not that learned about the Searl effect as you guys are, but from the short, description that I read in the anti-gravity book, Secrets of Anti-Gravity by Paul Ojala, he describes it as having those black magnets, the regular iron magnets, and then the neodymium is demagnetized. It's are you familiar with that version of the Searl, or did I get it wrong? Yes.
We used N40 and N50. I thought there might have been, I think that was as high as you can get. The magnets, unfortunately, are from China. They were, you could put them apart like this, a foot or so, 2 feet, and they're an inch in diameter, and they'll go boom with sparks.
Right, but what I was saying is that the from what I've read about the Searl effect, and I may be wrong, the neodymium is in there in its non-magnetized form, so the Curie temperature is irrelevant because it's non-magnetized.
I don't know if that's true. I don't think so.
I'll look it up in the book right now, and I'll get back to you.
Yeah,
because you sort of, maybe that's why he's imprinting it a certain way on the ring.
Paul, could I ask you to stop screen sharing? That's that green button down at the bottom.
I tell you what, it ain't happening. Let me log off and log back in. Okay?
Sure. Okay.
Oh, I did. Can you hear me?
Yeah, you're still here. So if you go to the window where you can see the people, right?
Yeah.
There should be a screen share button.
I got you in there. Nope. I just lost everybody. Here we go.
Oh, wait a sec. Stop sharing. There we go. I was able to do it for you. Okay. And now we are on gallery mode. We can see the audience here. Okay. My apologies. So Mark is looking it up. And what Mark was looking up was whether or not they start out, that's the striping, right? That you're talking about?
No, I kind of remember, I might be wrong about this, so don't really count it, but the neodymium is demagnetized in the rollers, or at least I think that's what I read over here. I'm going to check it out and find the source for it. I was just wondering whether he had any comment on that, and apparently he didn't. So we just move on to the next question. I'll bring it back up if I find it, okay?
Wonderful. Okay, so let me scroll down. So Robert O'Keefe is with us. And let me see, he was asking, did they look at the frequency in the magnetic walls? Robert, let me unmute you there.
There we go. Yeah, I have a question. Did you look at the different frequencies in the magnetic whirls on the basis that the combination of them frequencies could be creating the gravitational shielding? And when the device is not running stable and there's instabilities in the device, then frequencies in the whirls, the magnetic whirls around the device will be changing, creating that change in the gravitational losses and gains. That was
the amount of information we got from the Russian system, the Russian paper, was inconsequential. And we did not look at any frequencies whatsoever. We should have, but we had a limited budget, and I blew all the money on the device itself rather than going into instrumentation.
Yeah, beautiful piece of engineering.
It was it was definitely bulletproof, let's put it that way. Any other questions?
All right, thanks.
Okay, thanks, Robert. Okay, so let me see here, and I missed one, and I should apologize. I've got a lot of chats that I'm kind of jumping around. Let me see. I think Hector, you had a question about you were wondering if the rollers were shifting.
Oh yeah, no, I saw a video of one example, actually part of the paper that's being presented like online. I was looking while he was presenting, and it just seemed like the camera was catching like one or more set of rollers kind of like shifting in addition to just rotating. So I'm just thinking maybe a high-speed camera could confirm that there is no shifting periodically. Like they would roll, and then shift like an inch forward, and then everybody would shift like in a sequence. So that's just a simple idea that kind of came from watching the video and seeing that the camera frames were catching some kind of movement in addition to the regular rotational movement.
I think you might be reminding some of the stuff about the Kozyrev gyroscope experiments.
Okay, maybe that's what it was.
The
Very
factor
similar,
about something moving, shifting, you know, maybe that's a good effect. But as far as we were concerned, you got ball bearings in there. Everything is tight as much as possible.
Okay, so everything's kind of fixed, is what you're saying.
Yeah, yeah.
Oh no, that's okay. That definitely eliminates that probability.
Yeah, if I could jump in really quick, one of the things that makes this interesting, which I guess you could look at it as good or bad, depending on how you want to look at it, is Paul and then John Brandenburg, who is also with us, who I should pass to for some comments. They worked with Godin and Roshan's experiment as well as Searl, and they took bits and pieces from both. And so this is kind of a third experiment that combines, you know, their own innovation with basically Searl and Godin and Roshan. So.
Yeah.
Okay, let me see. Jeremiah was asking about, Jeremiah, are you still with us?
Yeah, I'm here.
Okay, sorry, I lost you on the screen. You were, there you go. And you were asking about Axial, right?
Right, so I took a look at the Searl effect generator a while back, and I studied it pretty extensively, but never attempted to build anything. And one of the interesting things I noticed that was strange about it were his roller magnets. Now I thought, why did he use a stack of 8 ring neodymiums in order to form his rollers before they were custom programming or encoding those rollers? And I thought, you know, what's the purpose of using 8 instead of just 1? And I looked into it deeper, and he goes into explain, and there's some artwork on it. I don't have it on hand right now to share with you guys, that shows if you roll one of those rollers along a flat plane, the north and south region produces a sinusoidal output over that course of the plane. So if you roll it across magnetic viewing film, basically what he did is every couple of degrees he would take one of the 8 neodymium magnets and rotate it by a certain percentage, and then he'd keep on rotating it by a certain percentage all the way up the stack to sort of form this axial spiral, this helix of the fields that would come up. And this would have created a different magnetic component as these things were rotating at high speed. There would have been a emotional magnetic flux that would have been moving upwards or downwards depending on their rotation, as well as there would have been a transmitted outwards axial flux. And this flux would have had a torsion to it in comparison to just simply having a wavefront. And I don't know how important it was, but I did notice that it was one of the key differences between his rollers and other systems I've seen. So maybe something to consider.
Well, the point here is that we didn't look at this, and I tell you what, we only saw little effects. And when we did something different, it was an important effect. Chances are his effects play a role. But the question here is, you know, have you ever gone to a junkyard where you had this big motor on a crane that lift up trash around?
Yeah, large electromagnet.
Yeah, he was using that for imprinting these rings. Now, I don't know about you, but I can't get hold of one of these big, huge magnets in the junkyard.
You can build one, though, for about $200. I'm not joking.
Oh, man. Well, where am I going to put it? In my backyard or something like that? You know?
I'm guessing your garage is full already, full of cool gadgets. Just
there you go. There you go. But, you know, it's the question here is, can you reproduce somebody else's work? And some of these problems are so complex that you can't do it. And I was raising this point at the last time we had this meeting when Podelnikov did the semiconductor not semiconductor, superconducting disk. He did it with 13 inches, moved it at 33,000 RPM, lost 2% to 3%. And somebody was looking at 6 inches that rotates at 400 RPM, and he sees no effect. So he says, I don't see any effects replicating his experiment, therefore his experiment's wrong. The problem is when you do an experiment, you have a certain art of what you're doing. Number
Right.
one,
You
care
have a
about
way
what
of
you're
doing things that you're used to.
Yeah. So if you're doing that, you care about it. Somebody else is doing it. They don't have the same motivation and the same care. And the details that you have to go through, it won't cover all the details. Now, we did not cover the imprinting problem for the first 3 series. I feel that the last effect was indeed imprinted somehow, but I don't know how. You just run over that damn high mu 80 ring, and it, you don't see anything that, whoops, stop, go, stop. You don't see that. When it's off, there's no magnetism on there again. So he said, gee, it's not restored hysteresis effects. And as soon as you put that damn carousel on top of it, boom. Now, the amount of magnets that we had in there, I would argue it's about this, the strength of that was like 2 Tesla. And when you go to an MRI, you have a 1 to 3 Tesla to do that. And some people used to say that 2 Tesla could bend a steel beam. We had a lot of magnets in there, and the effects were really different. Any other questions?
No, that pretty much covers it. I mean, maybe we can talk sometime about doing a couple of changes. I've got a lot of experience in the calibration industry, and I might be able to help you guys out solve some of your noise and anomalous problems in measurement. But it's something that we can talk about after the fact.
Yeah.
If you're interested.
Oh, there's Ron has a question. Okay. Oh, you muted, Ron.
I gotta see. Am I unmuted?
You are now, sir.
Ah, okay. There's something that I circulate. I have certain things that are part of my religion, and I don't know how many people are familiar with the work of Professor Francesco Muller.
No.
Nobody. What I will mention, Francesco Muller is Florida State University is the big magnetic research center. I think they have the world's biggest magnet, but it is a toroid. It's a high amperage solenoid twist, and that generates the highest field. But what I wanted to say with Paul was the stator of this device made of aluminum. That you had the magnetic rings that rolled around. What did they roll on aluminum? The hub.
The major ring is on high mu 80. There is a shell inside of it. These are all concentric shells where it's aluminum and copper. And go ahead.
You have an inductive effect between the magnet and the metal. No?
Yeah.
Well, here's with Francesco Muller. He gets, when you read through, I take the word from superconductors on pending line fluxes in space, that when you have a superconductor, you cool down, they use the word flux pinning. The lines of force are pinned into space. I think there's a possibility that when your rollers are rotating around the external annulus of the ring, what you have an inductive effect, and you have I guess you've looked at the field when it's rolling above the laminates, because I think what's happening, that even though things are rolling, you have something that is pinned in space. The concept of I mentioned last time, it's essential to understand the one piece homopolar generator in which the magnet is bonded to the armature and they both spin. And what happens is, I should go offline and just, I don't know who I can send it to, just send the paper, then come back online at a later point. But anyhow, I think the work of Francesco Muller, because it's anti-special relativity. What happens is,
Ron, the thing that we were doing with that latest design was to try and get all these things coming together.
Yeah, it's
rather than this way. And I'm thinking of Giorgio Fontana's gravity wave propulsor, where you have a spacecraft going like this, generating 4 or 5 transmitters here above it, and it generates a gravitational field, and the spacecraft goes up.
Yeah. Okay.
So I was trying to think of something just like that.
Yeah. Maybe you don't need a cone. I can see the need for a cone to get a differential. The cone makes sense, but what I'm going to go offline. Maybe I'll send it to Tim. Then I'll come back online in a while.
You got my email. Let's, you know where I live.
If anybody wants, the descriptors are Francesco Muller, M-U-L-L-E-R. It's special relativity and induction. And what happens is it's possible to anchor, you can anchor lines of force in space and then react against, because back when I haven't been in contact with Frank Mead. I guess most people know Frank Mead here.
Yeah.
Yeah. So anyhow, with the one-piece homopolar generator, when they load it, when they drew current from it, they made the comment, it would stop as though an air brake were applied through it. And the truth of the matter is, the strength of the brushes and the leads to the brushes could not withstand that force. So what happened is it was drawing out the energy from space. So there was a space coupling, because everybody blames the one homopolar generator, and they say, well, everything is reactive forces against the brushes, even with De Palma. I made a homopolar motor, and the whole crux of De Palma's homopolar generator, he says it would not motor. If you dumped energy into a homopolar motor, it would not spin, and it does spin. So anyhow, I'll just send the link wherever.
Okay. Ron, you're talking about these guys from Florida. Is this the guys with the 40 Tesla magnets?
Yeah. Well, what is it's called?
The thing is, they run it and then it collapses.
Yeah, because what it is, they are not really magnets. What they have is a corkscrew solenoid, and they force water through it with a fire hose to cool it down, and then they pump in extremely high amperages, and from that helix you get an intense field. It actually crushes metal, but it's called the word is bitter solenoid. Is that familiar to anybody? It was developed at the Bitter Laboratories at MIT. So, but what I will do, maybe later on, it's not important, but I think to get you to your path, this paper by Francesco Muller and the concept of pinning lines of force in space, and then you can react against them. Once you have these strings in space, you never think that you can react to a field standing in space. But if you look at what Muller is saying, you put a line a magnetic line in space, and then it's pinned there, and then you can react against it. So I think that's where you are, and I'll give everybody a copy. So that's it for now. So thanks again.
Ron, just before you run, Ron, one question for you real quick. Did you work with Podklinov?
I did.
Is it can we PM you? I sent you a message, but I'm not sure if you're seeing your direct messages. You're about to go.
Yeah, I'm not that familiar. I
kind of figured I'd just ask you because it's a lot easier. But we're replicating this month Podklinov, and we could really use your advice.
Oh, well, in terms of you're using 1, 2, 3s?
No, that's a few things that we could talk about. We have some superconductors we don't think they're large enough, and we have to work about bonding them and deal with the bilayer issue. So there are just a lot of questions.
Well, I'll just mention one thing. Back in the early days of superconduction, I live. I'm 30 miles from Princeton. Halfway between me is Lambertville Ceramic, and they were pressing, isostatically pressing 1, 2, 3s, barium, yttrium, copper oxide superconductors, and they claimed the liquid nitrogen superconductor was actually, these were Chinese professors. They said it was really invented in China, and they were making them at Lambertville Ceramic, and they said if they want to, they can sue us, and I would get free 1, 2, 3 superconductors. And when I found out, keep them away from moisture, they will crumble.
Well, Ron, let me pause you with that. Let me pause you with that, Jeremiah, and you can loop back around offline.
Okay, yeah, okay.
And in fact, we may do another conference where we talk about Pogklanov. But
okay, good. Okay, that's good. Okay, I'll be out. So I got. Okay, hey, it's fun.
Okay, sorry about that. Paul, I actually had a quick question. This would be a more general question for you, but okay, so the Searl effect generator and the Godin and Roshan device were both inspirations from this. And going into this, yourself and John, right? Because you guys worked on this together. And I guess I should probably loop John in here as well. Has this changed your thoughts or opinions about either Searl or Godin and Roshan? I mean, because I think there are a lot of questions, right? Like, how legit are they? Especially in Searl's case, there are just a lot of questions there. Has this changed your guys' feelings about those?
Tom Vallone put out a few books on Searl, and some of them showed interesting pictures. And he made claims that he was having flying saucers flying around in the 60s. And he was going to build this huge, big one that was like 20 feet in diameter. And it looks serious as hell. And the outer diameter would have a Searl device in there. But he had a problem. I don't know if you're aware of the problem, and that was he put a device on his house to generate electricity. He cut off the electricity to his house. After a year or so, the power supply people took him to court that he was somehow generating electricity and he was stealing their current. So he had gone to jail for a time, and he had always told his wife that he's going to get benighted because of his equipment. And she said, "You're full of it," typical wife. And the house caught fire. So all of his devices burned up, and he never could get back to it. Okay, that sounds very interesting in terms of history. Like I said, I think he discovered some natural phenomenon. I don't think he has his handle on it. So let me go with that. For Godin and Roshan, they were trying to build a device that would generate 50 megawatts of electrical power. And they wanted to sell it for about $50 million. It didn't work. So their approach was toward looking at financial, commercial aspects. And I guess we doubt some of the things that they said. And when you look at the roller that they put together with the slabs, that's not concentric like we had with ours, or Searl for that matter. Maybe they caused something else. I don't know. I couldn't make any judgment about it unless I ran the device. But from what I understand, the second one was a hot rod on the first, and it was a total loss. And the third one's another question. So it's hard to say. The effects from it look real, but if you look at del cross S, if you have the pointing vector in one direction, let's say just radially, the curl product of the curl goes to zero. So something else is going on. In other words, for these effects, the pointing vector has got to be a function of r and theta. And the same thing holds with that v. And the same thing holds for that gravity. You know, I've done work on gravity where I end up with a curl term in there for gravity. And if you just use one direction, that curl term disappears. If that's the case, then what's causing these effects? Is it these cross currents? And can I do that cheaper or more realistic? instead of putting together a device like this. For example, when you talk to the Patelnikov disk, NASA tried to make a copy of the 12-inch disk. And when they cooled it, it cracked. They didn't know there was a lip on there and you needed rotational effect. Maybe if you looked at that damaged one and you ran a electric field with a circular polarization on it, you might have been able to duplicate the same effects. So you might not need the physical rotation when you can do it electromagnetically. I don't know, but I'd like to see somebody try that. And I'd like to help them do that, but that's another issue. So it's hard to say. Something went there, it looked real. How they got there is questionable. Should there be more effort there? Probably. I have to agree with it because right now in my directions, I'm going into that equation where it's a local gravitational field and looking at gravity. And there's circulation effects out there. It's just amazing. It just comes out and I don't think it's dark energy or dark matter, but I think it's just pure due to circulation. So we have to take that into account. Now we don't do that because, well, we got to linearize the problem and we don't want to do that because the mathematics are tough and stuff like this, or I don't know how to do that, but I think we have to do that. That's at least my opinion.
Yeah. Well, thank you, Paul. And so I think, and I guess Mark could probably comment on this. So Mark had talked about opening it up for kind of a general discussion. Mark, do you still want to do that? Let me put it on gallery view real quick.
Yeah, I'll just keep it as an open discussion. If there's no more direct questions for Paul, I actually had a question though. I was reading in Paul Violet's book, Antigravity Propulsion, Secrets of Antigravity Propulsion. I consider this my antigravity propulsion Bible. It says here that they applied a 20,000 volt DC potential. Did you guys do anything like that?
Nope. That type of thing scared the shit out of me. Scared the daylights out of me.
Oh, we're going to go up to 1 million with a Mark's generator. We'll show you that.
That's the other question. We got to look at the Patelnikov gravity pulse device.
Yeah,
and it requires millions of volts. And yeah, we got to look at it. But you know,
we're gonna do it. All these experiments, we plan on doing them live here on APEC, and I actually plan on getting a couple separate cameras so that we can do this gallery view thing, and I could have one camera, logged in from a separate viewpoint, and then one camera will be a laptop that will, give you all the live data that's coming in. We got equipment from Vernier, and the software allows for like 8 devices at once with 100,000 samples per second. So you'll all be able to be in the laboratory with us as we're doing the experiments and, point out any mistakes we might make. It's hard to give a timeline on something like that too, because the nature of engineering, things are going to break. So it might be an hour, it might be 10 minutes. We might have to postpone and come back, but it's going to be actual live experimentation happening straight from the lab on here on APEC once we have stuff ready.
Oh, Paul, if I could jump in real quick. So Todd Desiato mentioned this in chat, and I should, but I wanted to ask, basically what he was asking was, he was saying, per the engineering model, gravity is the loss of power that you're experiencing. And he was suspecting that the forward gradient in power, the power loss, is what was causing the weight loss. Now, I wanted to expand on that also, and hopefully he won't beat me, because one of the things I think you'd mentioned this was the device itself, the temperature went up, but I believe I mentioned you mentioned it running cold at some point too, right? That's something that Searl had talked about.
No, the Russians said that theirs got cold.
Okay.
But you don't know where they measured those devices. In other words, was it near the motor? And was it on the ring? And the other thing too is you're spinning this thing it's got to be balanced. We had problems to do that. We had to use, although everything is symmetric as far as the machining was done, it was not balanced. So there was some oscillations you had to get rid of. And we did that by putting washers with tape at certain locations.
Yeah. Well, and then let me see again. I should unmute. John, are you with us?
I sure am.
Yeah. Let me see. And it looks like you don't have your camera on. Do you have something over your camera?
I have a lamp and the bulb burned out and I can't get anyway.
Oh.
So I'm sorry. It's just dark. Anyway.
Well, if I could ask
I'll
John, if I could ask you to,
I'll put up a picture of myself when I give my brief presentation. So.
Okay.
No.
Well, and John, thank you for joining us. So the reason I was excited that you could join us was, again, John did the hardcore physics work, right, Paul? So you managed the engineering on this. Orbitech built a lot of the components, and then John did a lot of the physics.
Actually, Tim, I did not do the hardcore engineering. That was done. Paul, you had an engineer basically put it together, and he did a really good job because.
Wait, time out, John. John, that was me. That was
you?
Yeah.
Well, you're an engineer, right?
You bet your ass.
John, you may be able to turn them.
When we were spinning that thing up in the control room, we used a room that was used to test rocket engines. And you could feel the tension in the technicians of Orbitech as we spun this thing up. They expected it to come flying apart and be flinging those magnet rollers at like 500 miles an hour into the walls, and it didn't happen. The thing hung together just amazingly well. I was just deeply impressed. And of course, we got some interesting physics results, but just the fact that we could actually, make that device and have it operate was just really, really an accomplishment in itself.